Hi students, this is Sumalata. Welcome to Learners Chemistry channel. In this session we are going to learn about preparation and properties of aromatic hydrocarbons. See, if you are not subscribed this channel, subscribe this one. Share these videos to the students or children who are having chemistry is one of their subject. These videos may helpful to them. And another one is if you have any doubts, drop your words in comment section. And if you want explanation for any particular topic, those topics also please mention in comment section. Coming to our topic, see here, before this one, what are the physical properties of aromatic hydrocarbons? All aromatic hydrocarbons are the colorless solid or liquids. These are used as suppose you can take naphthalene balls. Naphthalene balls we are using in toilets or wash basins as a moth repellent agents. And another one is these naphthalene balls we are using as a cloth preservatives also. Okay, these aromatic hydrocarbons are the good smell in nature. Okay, coming to preparation of benzene. See here, benzene in commercial way it is prepared from coal. Okay, commercial way prepared from coal. In laboratory it is prepared from cyclic polymerization of ethine. Okay, this is one method. See, this is the ethine. 3 moles of ethine you have to take. CH triple bond CH. This is another molecule of ethine. See, the shifting of pi bonds taking place here. Then benzene will be formed. This is the cyclic polymerization of ethine. Okay, coming to next one. Next preparation method is the decarboxylation of aromatic acids. Okay, for especially decarboxylation we are going to take sodium salts of benzoic acid. Okay, second preparation method is the decarboxylation of aromatic acids. Okay, see, sodium salts of benzoic acid COO-Na. Okay, this is the sodium salts of benzoic acid. Benzoic acid on reacting with soda lime. NaOH CaO is the soda lime. Then benzene will be formed. The decarboxylation takes place in the form of Na2CO3. Okay, this is one type of preparation method. See, this is the benzene. This is sodium carbonate. The next preparation method is reduction of phenol. See, in reduction of phenol, what we are going to take? Phenol is in the form of a vapor state. Okay, phenol vapors will be passed on zinc dust while heating. Okay, see, reduction of phenol. Phenol vapors okay, phenol vapors passed on zinc dust under heating. What happens here? Benzene will be formed. The byproduct is the zinc oxide. Okay, this is another preparation method. Coming to chemical properties of aromatic hydrocarbons. See, especially aromatic hydrocarbons are characterized by the electrophilic substitution reactions under normal conditions. If special conditions are there, then they will undergo addition, oxidation and reduction also. See, what are the substitution reactions? See, the general electrophilic substitution reactions are the nitration. Second one is hallucination. Third one is sulfonation. Okay. And fourth one is Friedel Crafts Acylation. Okay. And fifth one is Friedel Crafts Alkylation. These are the main substitution reactions involved in with benzene ring. Okay. We will go to discuss about the first one. What is the nitration on a benzene? See, benzene on reacting with concentrated sulfuric acid and concentrated nitric acid, okay, in presence of heating, it will form nitrobenzene. See, this is the benzene ring. It can involve, reacting with concentrated H2SO4 plus concentrated HNO3. See, this mixture is known as this concentrated H2SO4 and concentrated HNO3 is known as nitrating mixture. Okay, this is the nitrating mixture. See, if heating is there, then what happens here? Nitrobenzene will be formed and dehydration also will takes place here. This is the nitrobenzene. See, in this case, the concentrated H2SO4 acting as a proton donor, okay, that means acid. Concentrated HNO3 acting as a proton acceptor, that means HNO3 acting as a base, proton donor. This is the formation of electrophile, students. See what happens here. HO, H, this is plus, okay. After that, HSO4 minus will be formed. See, from this one, water will be liberated and NO2 plus nitronium ion will be formed. This nitronium ion acting as a electrophile. This electrophile will be going to attack on this benzene ring. Okay, this is about nitration. See, students, the second reaction is hallucination. How hallucination taking place on benzene? See, especially if benzene reacting with halogens, those chlorine or bromine, okay, those two are involved in hallucination in presence of Lewis acids like anhydrous AlCl3 or FeCl3 or FeBr3. These are the Lewis acids acting as a acids. Okay. See, benzene on reacting with chlorine, okay, in presence of anhydrous AlCl3, chlorobenzene will be formed. This is the chlorobenzene, okay, plus HCl gas will be liberated, okay. HCl will also be formed. See, here what is the mechanism for electrophile formation? This is the chlorine molecule. This is anhydrous AlCl3. What happens here? This anhydrous AlCl3 attracts Cl minus, that means chlorine with one lone pair. So AlCl4 minus plus Cl plus, this is the chloronium ion. Chloronium ion will be formed. This is acting as an electrophile. This chloronium ion Cl plus will try to attack on benzene ring. Then chlorobenzene will be formed. Coming to next one, see, if excess of chlorine, if we can take, what happens? See students, excess of chlorine, if you can take Cl2 3 moles of chlorine, then it can replace all hydrogen atoms present on a benzene ring, okay. See, this is the hexachlorobenzene. This is the hexachlorobenzene. If bromine is, instead of chlorine, bromine is there, what happens? Bromination is there, anhydrous AlCl3, then bromobenzene will be formed, okay. This is the bromobenzene. If excess of bromine is there, what happens, students? Here just try to observe once here. See, excess of bromine, in case if you can take 2 moles of bromine, what happens here? See, here this double bond will be broken up. Instead of that double bond, bromine atoms will be attached, okay. Then it can loses its aromatic nature. So limited condition of electrophilic reagent can be used, okay. Coming to next one, sulfonation. Here in sulfonation, benzene on reacting with fuming sulfuric acid. See, fuming sulfuric acid is the concentrated H2SO4 SO3. This is the concentrated one. This is fuming sulfuric acid. It is also known as oleum, okay. Under heating, it can give benzene sulfonic acid. Benzene sulfonic acid, and here also dehydration takes place, okay. Here just try to see formation of electrophile HOSO3H, okay. See, here proton addition will be taking place. See, on this hydrogen HOH, S double bond O, H. What happens here? This water molecule and this H plus can come out and come out as in the form of H3O plus. See here, this SO3 will acting as an electrophile. See, this double bond will be shifted towards oxygen, then S double bond O minus S plus. This is acting as an electrophile, then it will going to be attack on, I think it is not visible to you. See, if this double bond shifted that side, what happens here? S plus and O minus, this can acting as an electrophile, then this will going to be attack on a benzene ring. This is about sulfonation. Next one is Friedel Crafts alkyl. See, benzene on reacting with alkyl halides in presence of anhydrous AlCl3. Anhydrous AlCl3 acting as a Lewis acid. CH3X or CH3Cl you can use. CH3Cl, anhydrous AlCl3. What happens here? Methyl benzene or alkyl benzene. Methyl benzene will be formed and hydrochloric acid is the byproduct. See, instead of methyl chloride, you can take ethyl chloride. C2H5Cl, same anhydrous AlCl3. Then what happens here? C2 ethyl benzene will be formed, C2H5. Here also HCl will be liberated. See, this is the ethyl benzene. If N-propyl halide will be reacting with benzene, what happens? Which one is the, what is the product? Just try to observe once. See, this is the N-propyl CH2Cl is the N-propyl halide, anhydrous AlCl3. See here, I think you may directly write N-propyl, N-propyl benzene is the product, but that is not the product here. The main product is isopropyl benzene is the product. Isopropyl benzene. Why? Because see, once I will explain now. See, CH3, CH2, Cl. If Cl minus will come out, what happens? Primary carbocation will be formed. When compared to primary carbocation, secondary carbocation is the more stable. So that what happens? From second carbon to first carbon, one hydrogen will be shifted in the form of hydride ion, CH3, CH plus CH3. This is the secondary carbocation. This is more stable when compared to primary one. Then after it can going to attack on benzene ring. Okay. Now this is about Friedel-Crafts alkylation. Next, coming to Friedel-Crafts acylation. In Friedel-Crafts acylation, what happens? Benzene on reacting with acid chlorides or acid anhydrides, then it will give acetophenone. Okay, acetophenone is the product here. See, this is the benzene reacting with acetyl chloride CH3COCl in presence of anhydrous AlCl3. What happens here? Acetophenone, C double bond O, CH3 plus HCl will be formed. This is the acetophenone and this is the acetyl chloride. Okay, coming to next one, benzene on reacting with acetic anhydride CH3CO twice. This is the acetic anhydride. Acetic anhydride. Okay, this is in presence of same anhydrous AlCl3. This will also give acetophenone and acetic acid is the byproduct. CH3COOH is the byproduct. Sorry, in this case, yes, HCl is the byproduct. In this case, acetic acid is the byproduct. These are the substitution reactions of benzene or aromatic hydrocarbons. Coming to if addition reactions are taking place, what happens? Let's see now. See, benzene on reacting with hydrogen. See, you already know under special conditions only. Okay, addition reactions are taking place under special conditions. If benzene reacting with 3 moles of hydrogen, what happens here? Nickel acting as a catalyst, okay, and high temperature or pressure, okay. Nickel acting as a catalyst, high temperature or pressure, it will gives, see, all double bonds present in, or all pi bonds present in benzene will be replaced with these hydrogens and it can form cyclohexane, okay. This is a non-aromatic compound. If we already discussed in previous class, if it is involved in addition reactions, then it can lose its aromatic nature. See, if benzene involved in reaction with chlorine in presence of UV light, okay, ultraviolet light and 500 Kelvin temperature, what happens here? All double bonds will be replaced with chlorine atoms. Here benzene hexachloride will be formed. Benzene hexachloride, this is also known as gammaxime. Hexachloride, this is also known as gammaxime, okay. These are the addition reactions taking place on benzene. If oxidation is taking place on benzene, what happens? See here, see, oxidation, C6H6 plus 15/2O2 under heating, what happens here? 6 CO2 molecules will be formed and 3 water molecules. This is the combustion reaction, children. Combustion, okay. Combustion reaction. The general combustion reaction for all hydrocarbons, CXHY plus X plus Y by 4 O2 X CO2 plus Y by 2 H2O. This is the general combustion reaction for all hydrocarbons, okay. This is about preparation and chemical properties of aromatic hydrocarbons.